Here we have the data for the psychology exam scores. Basically, the data says that there's 3 exams given to the students of this psychology class. And we have the final grade for the students of this psychology class. What we're trying to figure out is which of the exams is the best predictor of what the student's final exam performance will be. So the idea would be that we already know these 3 exam scores, and we're trying to figure out what the relationship is to the final exam scores. That means what we know is exam 1 through 3, and what we're trying to find out is final, at least as far as the regression is concerned. So we go to data, data analysis, regression, and our Y range, what we're trying to find out is our final exam. And our X range, what we already know, are our other 3 exams. Because I included the first row, which had the words on it, I will check labels and click OK. Now we have our regression results. Our R squared, which tells us the amount of the variation in the data that's explained by this equation, is 98.9%, which is awesome. So we like this regression as far as that's concerned. Our p-values, however, our p-value for exam 3 is 2.08 times 10 to the negative 10, which is a very low score, which is awesome. Our p-value for exam 2 is 2.46 times 10 to the negative 5, which is also very low, though not quite as low as the p-value for exam 3, which is also very awesome. Now our p-value for exam 1 is 0.007, or 0.7%, higher than the p-values of the other 2, so this has less of a chance of being a part of the answer, but still so low that it's almost definitely part of the answer. So we're going to keep that. However, the p-value for our intercept is 26%. So there's a 26% chance that there is no intercept, there is no constant in this equation. And so given that, I'm going to go run my regression again. And this time, I'm going to tell it constant is 0. Now, our regression before, the R squared was 98.9. Now our R squared is 99.9%. It's even better, which is awesome. And all of the p-values that we have available to us are less than 0.05, or less than 5%. So we like everything we have here. So our equation is the final exam score is equal to, the final exam score is equal to 0.3559 times exam 1 plus 0.53 times exam 2. Now I'm just rounding here. You can feel perfectly comfortable in using the entire coefficient, plus 1.127 times exam 3. Now, before we've talked about the p-values, and we've talked about how and what they mean, and we've talked about the coefficients, but we haven't talked about what they mean. Here we have 3 coefficients for 3 different variables, our exam 1, exam 2, and exam 3 scores. The coefficient for exam 1 is 0.35, the coefficient for exam 2 is 0.5, and the coefficient for exam 3 is 0.112, which means that exam 2 contributes more to the final exam grade than exam 1, and exam 3 contributes more to the final exam grade than both of the other 2. So if we had to choose what is the best predictor of the final exam score, we would have to go with exam 3 as being the best predictor. This is the equation described by the regression, but the answer to the question, what is the best predictor, it is exam 3. Now, putting this equation into into action. Let's go ahead and copy it, put it on the sheet with our data. What are we looking at here? So we could have two values here as inputs, and the final exam grade will equal to 0.3559 times exam 1 plus 0.53 times exam 2 plus 1.127 times exam 3. So we know that if I got a 70 on the first exam, and then I got a 90 and another 90, I have a 174. Whereas if I have a 90, and then a 70, I have a 158. So see how it's changing based on when we get the 70? All of this comes from our equation.